Suppose y varies directly as x. If y equals 5 when x equals 40, find k and the equation for y. Okay, so a lot going on here, but there's some key equations that go with this kind of exercise. Let's see. Y varies directly as x. What this means is y is kind of the same as x, except for there's some kind of constant in there. This could be 5 or something, right? Just imagine k is a number, so k is a constant. But what this means is as x goes up, y goes up, right? So they go up and down together. That's what direct variation means. An example of direct variation might be something like we could let x be the number of hours studied for an exam and y be the score on the exam. Right? Those are going to go up and down together. You spend more hours studying, the score goes up. Less hours studying, score comes down. Right? So that's an example of direct variation. There are many other examples. So there's always an approach to these problems. You use the information given to solve for k, to find k, and then you get a new equation using the new k. So it gives you these two data points, or I guess this is really just one data point. Use these to find k. And then write a new equation. Okay, so let's do it. Okay, so we start with this. It says direct varies directly, so we have direct variation. So we say, okay, y equals kx, but y is 5 when x is 40. So I just plugged in 5 for y and 40 for x, and now we solve for k. Okay, well, k then equals 5 divided by 40. I just divided both sides by 40, and then we can simplify that down to 1/8. Okay, so far so good. And now we write a new equation. So we go back to this. It's still direct variation. So now that we have our k, we have a new equation, which is basically the old equation, but now we have a value for k instead of the letter k. So our new equation is y equals 1/8 x. That's the new equation.